In this video, we are going to analyze a circuit with independent current source, IS, and dependent current source, Vx over 6. As you can see here, dependent current source is represented by a diamond notation and is called voltage-controlled current source. And as you can see, its current value depends on the voltage across resistor R1, which is Vax. The goal of this example is to find the voltage across the load resistor RL. To start, let's define this node as a node 1 and this node as node 2. And here is the common node with zero potential. For node 1, we assume that the current I1 is leaving the junction or node and current I2 is going to the junction. And of course, IS is going to the junction as well. The same way for node 2, we assume both currents I2 and IL are leaving the junction, and dependent current Vx over 6 is going to the junction. According to Kirchhoff current law, also called KCL, the total current entering a junction or node in electrical circuit must equal the total current leaving it. So let's write the KCL equation for node 1. For I1, by Ohm's law, we will have by substituting the values into the KCL equation and rearranging, we will get let's call this equation A. Now we write a KCL equation for node 2. And after rearranging, we will have let's call this equation B. As you may notice by looking at the equations A and B, we have two equations with three unknown variables. So we need another equation to help us to find the unknown variables. As you can see here, based on the direction of the currents we assumed before, the voltage across the resistor RL should be equal to the sum of the voltage across resistor R1 and R2. So let's write a Kirchhoff voltage law, also called KVL. And we can rewrite this as now we replace IL with the equation B and substitute this expression with the known values. And we simplify this. Let's call this equation C. Now by combining the equation A and C and then simplifying, we will get now we plug I2 into the first KCL to obtain I1. By the way, if you like what you are watching, please hit the like button and also subscribe to the channel if you haven't done yet. Now back to the video. Since we have found the current flowing through the resistor R1, we now can calculate the value of Vx by Ohm's law. And from the equation B, we can calculate the current flowing through the load resistor RL. And again, by Ohm's law, we can find the voltage across the resistor RL. Now let's double check our findings. As you can see here in the node 1, 2 amp plus 1 amp enter to the node and 3 amp leaves the node. And in node 2, 4 amp enters to the node and 1 amp plus 3 amp leave the node. So our findings are correct. Thanks for following along and don't forget to like and subscribe if this helped you.